Now it is my pleasure to welcome Willem Uitendaal from Centexbel, who will present the PowerPoint. Thank you, Willem.
Thank you, Frederike, for the introduction. And then, okay. Yes. So my plan for today is to talk about the promising outlook of bio-based textiles and some of the background information on what can drive bio-based textiles to become more prominent and more important in the future. However, before that, a quick word about myself. So I am Willem Uitendaal. I work at Centexbel, which is a Belgian knowledge institute for the textiles and the plastics converting industry, working with about 180 people there in total on everything related to textiles, going from developing new materials, testing materials, and certain certification as well, such as the Ecotex labels. So when we talk about bio-based materials in Europe, the first thing we have to talk about is the European Green Deal. So the European Green Deal is kind of Europe's way to talk about and to tell Europe what the plans are with bio-based materials, what the drivers are, what the targets are. This European Green Deal is not focused purely on textiles. It's about all of the materials that are used within Europe in the building sector and so on. So there are a lot of key topics here, and a few of them are actually quite important for textiles. One of them is number 3, so industry for a clean and circular economy. So as part of a Green Deal, it's quite important that the textiles and the garments that we design in the future have this circularity in mind. And then the last one, and I think I'm standing in front of it, is number 8. And it's not because it's the last one that it's the least important. It's about zero pollution and toxic-free environments. So there, when we talk about textiles, it has a few implications. It's, for example, thinking about the colorants that we use, heavy metals, effluents that come from dyeing garments. Toxic-free environments also relates to microplastics. So, for example, microfibers that shed from your garments when you wash them. Also, this reduction of these microfibers are part of the European Green Deal. And related to this, Europe also published a textile strategy. So this is not some law, it's just a communication that shows where Europe is and where it strives to be related to textiles. And here as well you see some of the key points that I just highlighted. Garments should, on the one hand, be long-lived. So they should be durable, they should be built to last. This is kind of in reaction to the fast fashion, where garments should really be worn quite a lot, be durable. And on top of that, at the end of life, should be recyclable. So if you have a garment at the end of its life, we should be able to recycle it in some way or reuse it using different methods. However, it doesn't end with just recycling the garments that we have. It's also important to use recycled fibers in the new garments that we produce, and doing this free of hazardous chemicals. So, like I said before, these toxic-free environments also comes back in the European textile strategy. And a part of this is, in achieving this, is also having producers take responsibility. So there are EPR schemes being set up to make sure that producers become responsible for their garments, or at least know what is happening to their garments and where they end up. An important key topic here, which is not fully mentioned in this textile strategy, is microplastic release. Microplastics have gained a lot of traction and a lot of interest in the last few years. And just to give you an indication of the size of the problem, which is not only caused by textiles, is that there are about 14 million tons of microplastics on the ocean floors right now. A part of that is released by textiles, but there are multiple other sources. I think the largest one right now is car tires. But nevertheless, textiles is quite an important source, and 35% of the microplastics released into the oceans right now comes from washing synthetic textiles. So, for example, polyester garments you throw in the wash, a few of the fibers come off, but because everyone does this, it accumulates to quite significant quantities of microplastics that are being released into the environment. Because of this microplastics issue, Europe also created some kind of a pathway to reduce microfiber and microplastic release. And since we are here in a talk about bio-based materials, I want to highlight one specific way to reduce or remove microplastics from garments, and that is the use of natural instead of synthetic fibers. So if we use natural fibers that are able to biodegrade, these fibers will biodegrade away and not cause persistent microplastics. Of course, there are other means to reduce it, but nevertheless, using bio-based and biodegradable materials is the way to at least fully avoid these microplastics. So, with all of this background in mind, we come to, or at least came to one quite important conclusion, and that is that, at least in Europe, the future when it comes to garments is to make sure that garments are, on the one hand, bio-based, to make sure they are sustainable, to make sure that the resources that we use are renewable, that these garments are recyclable. It's not because we make something out of, for example, a cotton fiber, that we should throw it away afterwards. It's still beneficial to try and reuse these cotton fibers to make new textiles. And then finally, they should be biodegradable to deal with this microfiber issue that I just talked about. So how do we get there? Because it's all really nice talking about how we want to get to bio-based, but how do we actually get there? So when we talk about bio-based materials in textiles, there are, I would say, three large groups of ways to get to bio-based. The first one is to use traditional natural materials, the ones everyone knows, the one everyone wears. For example, cotton, wool, but also natural bast fibers such as linen or hemp can be used to make bio-based, biodegradable and recyclable garments. Besides those, because when we talk about traditional natural fibers, they are limited in some way by how much of it can be produced. There are other ways also to produce natural fibers. One of them is what I would call the novel natural materials. Here we talk about cellulosics. So cellulosics are materials made from cellulose. This can be, for example, using cotton, dissolving cotton and using that to make new fibers. The most commonly associated or known type of cellulosic fiber is a viscose or a lyocell material. As I explained, this can be done using cotton fibers, this can be made from wood, but all kinds of cellulosic waste, for example, even potato starch or straw waste, can be used to make cellulosic fibers. So the feedstock here is quite varied, it's quite large, and it's accessible. Which makes it quite interesting. A second one is looking at bacterial sources, and there one of the materials that is coming up is a bio-based polyester called PHA. It's a plastic material that is made in bacteria and in plants as some kind of fat layer within these bacteria if they need food at a later time. they will temporarily store this energy as a PHA. We can extract this from these bacteria, melt it and turn it into a biopolyester fiber that remains biodegradable. Quite an interesting material, but I would say currently their developments are still ongoing, but expect to see more of this in the coming years. And then the final one is bio-based plastics. So here we are not talking about materials that we can find back in nature. It's really materials that are made by humans, but using building blocks that we can find in nature. So here examples are the PET we all know that is used in textiles, is made of 2 building blocks. If you source those 2 building blocks to be bio-based, you have a bio-based PET. One of the examples there is even, for example, the plant bottle from Coca-Cola is an example of this bio-PET. Important to know is that we talk about bio-based plastics, that they are not always biodegradable. So for example, a bio-PET and a biopolyamide, they are identical to a classic PET and a classic polyamide. So they do not biodegrade, but in this case, they are sourced from renewable materials. However, other types of bio-based plastics do exist that are bio-based and biodegradable, such as, for example, a PLA and a PBS. The reason I talk about these materials so much is because when we look at the consumption of fibers, this is not just garments, but global textile market as a whole. There is a prediction that by 2050 we will see quite a drastic increase in how many fibers are used, textiles are used worldwide. There has been a study by the Nova Institute, which is a German institute that does a lot of studies related to bio-based materials. And what we see here is that 2011, 2013, steady growth. If this growth continues as we are doing right now, we will end up with needing well over 250 million tons of textile fibers by 2050. What is important here is that there are 2 graphs for 2050. The large one on the left is if we are continuing like usual, so the business as usual. We don't really try to force a shift towards bio-based materials. And the one on the right is if we really try to focus and work more towards using more and more bio-based materials, such as through the Green Deal within Europe. What we see here is that the blue bars, which symbolize cotton and wool, remain mostly stable, even towards 2050, largely because there is just only so much cotton and so much wool you can produce. However, when we go to 2050, what we see is that there are quite drastic increases in the amount of cellulosics and the amount of biopolymers that we are expected to use within the next 25 years. So you really see there that there is a prediction that these materials will really have to step up and be the way where we fulfill this driving demand for more and more textiles worldwide. Still, fossil-based materials will have their place in the textile market. Think also, for example, on technical textiles. But still, when we look at bio-based materials, they will be and remain quite important over the next coming years. So therefore, it's important to kind of gain the knowledge how to use them now, so that by 2050 we know how to use them well. So now that we know why it's needed, I also wanted to present just a few slides on some possible novelties, some new things coming out related to bio-based materials. So one of them is one of these novel natural materials when using cellulosics. So it's called hypercell. The difference between hypercell and a viscose or a lyocell process is that the chemicals used to produce this hypercell are much safer than for the viscose process. So in essence, this process simply dissolves cellulose in a solvent, spins a fiber out of it, and then fully recuperates the solvent to use it again. So it's a nice circular scheme where you input cellulose and you get a cellulosic fiber out of it. The advantage of this system as well is that it's quite compatible with a wide range of cellulosics. So within this Hearware project that Frederica already talked about, a few different types of materials were used, ranging from wood pulp to even straw. So the dress you see here and also the dress you see there on the right of the hanger is actually made using straw waste, and the color, or this golden color, actually comes from the straw itself. So it's possible to bleach it as well to get back down to a white color, but because of this nice golden color, in this case we decided to keep it. A next interesting material is a biopolymer. It's PLA. PLA is polylactic acid, so it's made from lactic acid. It's a bio-based polyester, so it's quite similar to PET in behavior. The big difference there is that it's slightly softer than PET, but it's not as temperature resistant. So when it comes to these PLA garments, we advise that they are perfectly capable if you wash them up to 40 degrees. 60 degrees is possible too, but it's not advised. And if you go higher, then you really will start to feel that these materials start to toughen up. However, for example, consumer garments that are mostly just washed at 40 degrees, it's perfectly fine. This PLA as well is capable to be dyed through a dope dyeing process, so while the fibers are spun, colorants can be included, very similar to how polyester can be dyed. Interesting as well is that this PLA it's a bio-based plastic, and it's compostable, which means that at the end of life, ideally you recycle it. If it's not recyclable, it can be composted together with, for example, food waste in an industrial composting bin. Another interesting material is this PHA I talked about. So it's a bacterial type of polyester. Once again, quite similar, I would say, in properties to PET or to this PLA. Spinning work there is still in progress. So institutes like Centex Bell are working on how we can spin this PHA into fibers. For some technical applications, it's already been done, but now we are fine-tuning it to make sure that it's compatible with garments as well. But I would say keep an eye out for this material in the future, because I'm quite sure that it will grow quite significantly. Mainly because it's one of the polyesters that does not produce any persistent microplastics. Additionally, the PHA can also be used as a way to print on garments. So, for example, as alternatives to currently used plastisol inks made from PVC, you could use this PHA as well. And then a final slide is also one on microfiber release mitigation. This is one that is technically, it's available already, but it's not available as something that mitigates microfiber release. In essence, by applying a finish of polyurethane dispersion or chitosan, materials that are currently commonly available, you can reduce microfiber release by 75% on polyester cotton fabrics and even 99% on polyester fabrics. So this is just a very thin finish of less than 1% of this polyurethane or chitosan in water. Applying this finish just drastically reduces the amount of microfibers that are shed by commonly used fabrics. And with that, I would like to close and give some kind of a conclusion. So first of all, as you could hear from the start of my talk, within Europe there is a lot of push, a lot of drive to work more and more towards bio-based, sustainable, biodegradable materials that do not harm the environment. Growth of these materials will be in part driven by these regulations, but as well by consumers that are becoming more and more aware of what happens with their clothing. The third option is that biodegradable materials can really provide one of the solutions to the issue we currently have related to microplastics and reduce the amount of permanent microplastics that are being released into the environment. And with that, I would like to close and thank you for your attention. If you have any questions, then there will be a Q&A after the next talk, and afterwards you can always come and talk to me as well.